has never had a problem with me, but I just need to really, really crazy, just crazy.
Test. Yeah, it's working. Okay, let's start with 5.4 first. Do you have any questions from the homework? There are about 2 problems from 5.4 in the homework, 2 or 3, but one would be a definite integral that to get the exact answer, you'd have to know the fundamental theorem of calculus. I mentioned that yesterday when we did 28. You would have to know to find the antiderivative, put in the upper limit, put in the lower limit, and then subtract. That would be a problem. And then there's a problem on the test, kind of like 35 through 38. I don't think I ask an exact value for that, but you would just have to know, even if you're going to punch it on a calculator, you would have to know that this area is given by the definite integral from 0 to pi of x plus sine x dx. And I think, if I remember correctly, the problem on the test asks you to set up the definite integral. So that's part A, write the definite integral that would give that area. And then part B is what's the value of that, or what is the area, the value of the definite integral. All right, so any questions from 5.4? All right. I'm going to save those word problems on the practice test for last, because I know that's the most difficult thing. Let's talk about the chapter 5 review. Do you have anything you need to ask from chapter 5 review? Go in once. Go in twice. Okay. Hey, I just remembered in 5.3, one of y'all needs to cough every once in a while so I know you're still there. In 5.3, I mentioned that we would need to talk about average, well, actually 2 things today. And I honestly, I can't remember. I don't think there's one of these on the test, but just let me mention it real quickly because this is where Calculus 2 starts. Average value of a function. If I've told you that one definition of the definite integral is area, another interpretation of the definite integral is accumulated value. It's adding up a bunch of stuff. So if you want to know the average y value on an integral, and if you just integrate f of x dx from a to b, you get the sum of all y values on the interval. And if you had the sum of all y values and you divided by the length of the interval, then that would give you the average y value on the interval. So the formula for average value is the definite integral from a to b of f of x dx divided by the length of the interval. The length of the interval is just b minus a. Dividing by b minus a is the same as multiplying by 1 over b minus a. So that's the average value formula. And on number 52, if I said find the average value of this function on the interval from 1 to 3, make sure you understand what it's giving you is the average y value. And Ivy and others, I say Ivy because you're the one that posed the question, but the average y value, it makes sense that that would have to do with area, because if I was trying to find the area of this region, the width would be from 0 to pi, so the width would be pi units. The average y value seems like what I should multiply times that width to find that area. All right, but we're not doing that on 52. 52 just says find the average value of the function, which is the average y value of the function. And so I would integrate from 1 to 3 of 4 times x squared plus 1 over x squared dx. And then that would give me the sum of all the y values, and divide that by the length of the interval, divide that by 2, or same thing as multiplying by 1/2. So you could punch that on the calculator and you'd have the average y value of that function on the interval from 1 to 3. And then the other thing that I told you I wanted to mention, it's just an application of the average value formula. The concentration of a certain drug during the first 24 hours after it has been administered can be approximated by this function for x's from 0 to 24 hours, where x is the time in hours after the medication is taken. P of x is the concentration in percent. Now, this seems like a very real life problem to me. Determine the average concentration of the drug in the bloodstream during the first 10 hours after the medication is taken. You just set up the definite integral from 0 to 10 of that function and divide it by the length of the interval. If you want the concentration during the first 10 hours, the length of that interval is 10. So evaluate the definite integral and divide by 10, or multiply it by 1 over 10. 12% would be the average concentration of the drug in the bloodstream the first 10 hours. All right, so last call for Chapter 5 review. All right, we can either look at the problems I typed on the practice test, or the problems that you copied down from my math lab. Somebody give me a problem from either one, whatever you feel like is most important to you.
I have my math lab problem, but it has
Okay.
like a drawing element to it, so I don't really know how to show you the drawing.
Do you have, in Zoom, do you have start video up at the top?
Yeah, I mean, I can show you it on my phone. It just might be a little hard to see.
Yeah, just hold it up to your camera if you're if you have video going, and I'll write it down and then everybody can see it better.
Okay.
Or another thing, hey, if anybody else has a My Math Lab question and that doesn't work well, just holding it up to your camera, take a picture of it and send it to me via Remind real quickly. We're all on Remind, so you could take a picture and attach it to a Remind message. Would be a good way to get it to me. Okay, let me see if I can make that bigger so I can see it.
One sec, I'm gonna try and pull up my own video and see if I can control it. Here we go.
Okay, all right, I see the picture. Let me try to draw it real quickly. This must say something about find the largest rectangle that can be inscribed in that triangle.
Yeah.
2, 3, 4, 5. 1, 2, 3, 4, 5. And what is that at the top? Is that
B.
8?
A B.
A B, okay. So there's some point, and that must be the point 0B, because it's on the y-axis. Is B representing a point there, Miss Ivy? The y-intercept?
Yeah, so there's a line that you're supposed to find equation for. And I think once you get me started, I just couldn't really figure out how to write an equation for the line.
All right. So, but that B is the y-intercept. Am I understanding what B represents? They have a capital B, it looks like, but is it the y-intercept?
Sure looks like it.
Okay. All right. So read me the problem. Exactly what does that problem say?
The given figure shows a rectangle inscribed in an isosceles right triangle whose hypotenuse is 10 units long. A is express the y-coordinate of P in terms of X.
Okay,
And then
stop right there. Let's take it one little thing at a time. An isosceles right triangle means that it has a right angle in it, and we can tell from your picture that the right angle is at the top, and the hypotenuse is 10, is why these 2 points on the x-axis are your x-intercepts are -5 and +5, which makes that distance 10. So far, so good?
Yeah.
All right, and the A part says find, read the A part again.
Express the y-coordinate of P in terms of X.
Express the y-coordinate of B.
Of P.
P? Where's
Yeah,
P? Oh, P is the point XY where the rectangle intersects the side of a triangle. All right, so express the y-coordinate of P in terms of B.
Of P in terms of X.
Oh, in terms of X. All right, I got it. Express the y-coordinate of P in terms of X. Well, we know that the base of that triangle is 10, and we know that the lengths of the two sides of the triangle are the same because this was an isosceles right triangle. And so if we call this side of the triangle L, the length of that side of the triangle L, and the length of this side of the triangle L, can you give me, and I don't know if this is what I need or not. Honestly, I haven't done this problem, so I'm just thinking through it. Could you give me a formula for finding L with that triangle?
Yeah, just the Pythagorean theorem.
Yeah, the Pythagorean theorem. L squared plus L squared is 10 squared. So 2L squared is 100 and L squared is 50. So L is the square root of 50. Now again, whether I need that, I'm not sure, but writing down something keeps my brain from just freezing up. All right, so L is the square root of 50, and y-coordinate of P in terms of X.
The hint on the problem says write an equation for the line AB.
Write an equation for what?
The line AB.
The line AB. I didn't put an A and a B on my picture. Is A at -5 and B at, where's A on your picture?
B is the point at the top, not
Yep.
the y-intercept. It's just a point.
Okay.
It's just point B.
Okay.
And then the right corner is A.
The right corner, this right here, is A. All right. So it's asking us, or the hint is to find the equation of the line from A to B. Well, the point A, since it's on the x-axis, the y is 0, the point A is 5, 0, and the point B is 0b. I'm going to use a little b for the y-intercept of point B and find the equation of that line. So the slope of that line would be b over 5, b minus 0 over 0 minus 5. Wait. Yeah, that's a negative 0 minus 5. That's a negative slope because the right side of that triangle is going downhill. So the slope of that line is negative b over 5, and the y-intercept, this one x is 0, that's b. So the equation of that line is y equals m, I'm going to write it as negative 1/5 b time plus b.
I can't really see what you're writing anymore.
Oh, I'm sorry.
It's okay.
Yeah, remind me when that happens. So y is 4/5 b. That's the equation of that line. And how is that helping me? We know that this is the equation of that line, and we know the distance between A and B is the square root of 50. How would that help? Honestly, I'm drawing a blank, and I should have done these problems before this morning, but I spent like 3 or 4 hours trying to put the fundamental theorem of calculus interpretation into words, and then I went outside and played in the flowers. Did anybody get this one or see what to do next?
I got it, but I'll have to look through my problems to remember exactly how I did it.
Ooh, look for that, Aiden.
For me, it was the very first one.
I think that I did not have scramble order checked, so that should be the same problem for everybody, unless I checked that box and forgot. But I meant for number 1 to be the same for everybody so we can talk about it.
Maybe it's the wording of the problem, because I could find the length in terms of x, but I don't know how to write the equation in terms of x.
Okay, so I found it.
Okay, talk to us.
Okay, so the coordinates, so the points A on the x-axis, on mine it was 21. Which one
Okay.
was it on the problem that you had? 5?
Yes.
Okay, so I'll use 5. So I used the equation of the line, and for the first
Similar
part,
to what we got right here, Aiden,
for
that
the y
equation.
something similar to that, except that I got that the y coordinates of the rectangle was 5 minus x, because x goes out to part way of the line.
Ooh.
And the line's length is 5. Or no, not the line's length, the height of the y-axis. I have a hard time explaining it, but
Okay. I tell you what, I think we could spend the rest of our time on this one and not answer any other questions. So what I'm gonna do is put a big star by this for myself, and pretty quickly after my pre-calculus Zoom is over, I will email you the solution to this one with words so that you can understand what I've done in every step. I just need to think about it off camera.
Okay.
Yeah, okay. I'll email you that one. I think I'll have time between 10 and 10:30. So yeah, be looking for it then.
Okay.
All right. Does somebody, thank you, Aiden, for jumping in. I think it's going to be difficult to talk through it with your solution having different numbers than our solution.
oh, yeah, definitely.
I appreciate that you got that and you were willing to share with us, but I think it's going to be, yeah, pretty different or pretty difficult with different numbers in it. All right. Does somebody have another one? From either My Math Lab or the practice test you printed.
I had a question on number 12. Let me take a picture of it for you.
Okay, all right, just send that to me. Any of others of you that have a question from My Math Lab, go ahead and take a picture of it and send it to me. And we'll just go through them as you send them to me via Remind. All right, got it, Miss McKenzie. I love technology right this minute. The diameter of a tree was 20 inches. During the following year, the circumference increased 4 inches. How much did the tree's diameter increase? And then there's a B part. So is that number 12 for everybody, or were the problems scrambled?
Number 12 for me.
Okay, yeah, I don't think I hit scrambled questions or scrambled problems. So the diameter of a tree was 20. And during the year, the circumference increased by 4 inches. What symbol, how could you write that down? I mean, of course, I could put it in using words, but using symbols, what is that?
So I took the equation for circumference. Circumference equals diameter times pi.
Mm-hmm.
Then I plugged in 20 for the diameter, and then I put a plus 4.
Okay, I'm still looking for what a symbol for what that 4 is.
4 is what was added to the circumference, right?
Yes.
Wouldn't that make it, if you were using C to represent the circumference, wouldn't that
Yes.
be the delta C?
Yes, that's what I was looking for. That's a change in circumference. That's a delta C. Delta C is 4. So it is true that circumference equals pi times diameter. So if I, let me think, take the derivative of both sides, I would get the change in C with respect to D is, what's the derivative of this right-hand side with respect to D? It's just a constant times D.
Would
If
it
that-
just be pi?
Yeah, just like if this was 5D, the derivative with respect to D would just be 5. The derivative of pi D with respect to D is just pi. And so we're talking differentials here. This is the differential in C. So the differential in C is pi times the differential in D. And I forgot what we were asked.
How much the diameter changed?
Okay, find how much the diameter has changed. So find delta D. Delta D would be the change in C divided by pi. And we have the change in C is 4. So 4 over pi would be the change in diameter. It really doesn't matter what the diameter was to start with as far as the A part goes. The change in diameter only depends on the change in circumference. It doesn't depend on what the diameter was to begin with. So the change in diameter, 4 divided by pi, looks like in the screenshot you sent me that was 1.2732. If the circumference changed 4 inches, the diameter changed about 1 1/4 inches, and that's all we were supposed to find in the A part. Ms. McKenzie, you got that part right, correct?
Yes.
Okay, so the B part says the estimated change in area. All right, so instead of a formula for circumference, we need a formula for area, and we know that area equals pi r squared. But the thing is, we don't know anything about r. We only know stuff about C and D. So is there a way I could get this formula in terms of, well, since I'm given delta C, is there a way I can get this formula in terms of C instead of R? If I want something to put in place of radius that has circumference in it, what's the relationship between circumference and radius? It's a formula. What's the formula that defines the relationship between circumference and radius?
Oh,
So what can I put in place of radius that would have a C in it instead of an R?
okay.
Okay, so that's radius in terms of circumference, because my equation can only involve the variables or the differential I'm trying to find. And since it said estimate the change in area, I'm looking for dA. My formula can only involve variables that I'm trying to find or variables that I know something about. I didn't know anything about the variable R, so I had to express R in terms of C, because the change in C is what I knew something about. So now we have A equals pi times, instead of R squared, C over 2 pi squared. And I would simplify that before I differentiated it. Is that right? or I may even, just because 4 pi is a constant, I may write that as 1 over 4 pi times c squared. Now we're not through because we haven't taken the derivative of anything, but are there any questions about how we got to this point? And Ms. McKenzie, even if there aren't any questions, even if you followed what I did, that's not the same as being able to do it yourself. Let me go back to how I knew that this is what we needed to do. I was asked for a change in area, so just to write something down, I wrote down my area formula. And then I thought, well, I can't differentiate that because I don't know anything about delta R. And then I thought, well, what do I know something about? I know something about delta C. So if there's a way that I could write R in terms of C, I'd be in good shape. That's the exact thoughts running through my head. And then what is the relationship between R and C? Well, I have a formula for that. Let's solve it for R, and then we can get A in terms of C. Does that thought process make sense?
Yeah.
Yeah, but I'm still not sure I could do it myself. It takes practice, but if you look back at 4.8, which is where these differential problems were, one of the steps was you have to get the thing you're looking for. Actually, this is true of all word problems. You have to get the thing you're looking for in terms of stuff that you know. And I just had to keep looking back and going, well, what is it that I know? How can I get A in terms of C or A in terms of delta C? Now that I finally have that, I'm going to take the derivative of both sides with respect to the independent variable. If I'd used x's instead of c's, x would be my independent variable. So here C is my independent variable. When I differentiate both sides of that equation, I have the change in A with respect to C equals X is your, or C is your independent variable, 1 over 4 pi is a constant. So 2 times 1 over 4 pi is 1 over 2 pi. Subtract 1 from the exponent. Where the differential in A is 1 over 2 pi times C times the change in C. Excuse me. Instead of DC, I could have used delta C there. And so even though the change in circumference didn't depend on the original area, or excuse me, the original diameter, the change in area does depend on the change in, let me try that again. C delta C. I don't have a value of C to put into this formula. Where am I going to get that? I know I'm going to put 4 in place of delta C.
Plug 20 in place of the original equation for circumference.
Are you saying this? If I know diameter, how can I find circumference?
Diameter times pi.
Yeah, the circumference is the diameter times pi. And so 20 pi is what I need to put in place of C. The change in A would be 1 over 2 pi times 20 pi times the change in C was 4, oops, I left out a 0. 1/2 pi times 20 pi times 4 would just be 40. And since that's a change in area, it's inches square. Miss McKenzie, that is a lot like the 3 problems on the momentum practice test that involve differentials are 8, 9, and 10. So make sure you do those 3 as well as however many of those I put in my math lab. And then there's one like 6 or 7 in my math lab, which all you have to do is find the derivative and then multiply both sides by dx, and you have the differential. So that will be an easy one. All right, has anybody else sent me a picture in Remind? Nope, I don't have any others.
I just have one more thing.
Okay, tell me.
It's not a question. It's just about on one of the problems, it counted me wrong, but only because I just rearranged the order in equation.
Okay, tell me which problem that is, Mackenzie, and I will go in and look at it. I'm going to do this after the test also. Several of you on the last test had answers equivalent to what my math lab counted as correct, and usually it notices those things. If it has AB and you have BA, then most of the time when I go in and look at the acceptable answers in my math lab, it will say either AB or BA is correct, but for some reason it didn't count the answer that some people gave as correct. So I went in and adjusted the grades, and I think some of you noticed your grade improved significantly after I went in and looked at everyone's answers one at a time. So I'm still going to do that this time. Miss McKenzie, which one are you saying it counted wrong just because the order was wrong? And I'll look at it for you.
It was number 20.
Okay. I will send you an email either giving you that I've given you credit for your number 20, or that you don't have any I in there, do you?
No, I do.
You do, okay. My son-in-law doesn't have an I in there. Either telling you that I've given you credit for number 20 or explaining why your answer is really not the same. Sometimes I get a email from a student, I know my answer's right, and my math lab's counting it wrong, and they're all upset. When I look at it, I can tell them, no, that's really not the same. All right, so look for an email about these 2 things.
Alrighty.
Does anyone else have question from anywhere? Going once, going twice. All right, let me say that y'all know how much I love teaching and how much I love my students. This has been a difficult semester for a lot of reasons, and I appreciate the kind thoughts and prayers that you've offered my family, and I've enjoyed teaching you calculus. I remember the day you discovered the derivative by writing a formula to calculate my average speed as I passed the Monterey exit between Dunkin' Donuts and the Nashville airport. That's one of the coolest moments of the semester. I hate that I didn't get to be with you in class for the rest of the semester, because y'all are an awesome group. You're hardworking, you're smart, you're going to be fine, whatever you pursue after this. I hope that I get to see some of you in Cal too, but I know that may not work out. Some of you may need to take Cal 2 this fall in Harriman, and I understand that, and you'll be fine. I'm not worried about you. I'm just sad that I don't get to teach you that. So I just wanted to let you know, in case I don't have you in another class, that I appreciate you. I think you're awesome, and if there's anything I can do for you, let me know. Okie dokie.
Thank you.
All right, Mr. Joseph, this is my last time saying goodbye to Jolie.
Yep.
That makes me sad. Jolie and I go way back. All right, y'all have a great day, and the test tomorrow, did I say 8 to 9:30?
Yeah.
Okay,
Woo!
all right. Y'all have a great day.
Bye.
Bye-bye.
Bye.